Good morning, everybody. Brian here. Welcome back, and we are going to continue on our intro to networking. And today we're answering the question, how do routes get into the routing table? Short answer, either you tell the router about the network or you set up a routing table so they can share with each other. I think you're going to want to know more, so stick around. Let's get into it. Whether you're using a layer 3 switch or a router, it's that routing table that gets used to decide where to send routed traffic. But like we said, how does the routing table get populated, right? How do those routes get into there? Well, it's either going to be because you put an IP address on an interface, like a VLAN or a port, or you set up a static route, or you set up some routing protocol that allows those different devices to share what they know with each other. And, Tiny Brian? Yeah, Tiny Brian. Okay, here we go. So I've done a little prep work here, and what I've got going is these 4 different virtual routers, layer 3 switches, are all set up with a bunch of interfaces running OSPF as well, and also some static routes up here that point up top. And we're just using static routes to get up to here. This is a variation on the classic access, distribution, and core networks, though you wouldn't usually use static networks to point up to your core. Wanted to have plenty of different networks for us to look at. So that's what we're dealing with. But I want to go nail a little bit down, because what we're going to see when we go looking in that routing table in just a moment is that we're going to have some connected routes, some static routes, and for our purposes, OSPF. But generally speaking, what we'd be looking at is some sort of routing protocol. And OSPF is just an example of that. While it's not what we've got here, certainly, you might also, well, I was going to say you might also run into it, hopefully not anymore, but maybe anyway. You might run into RIP, OSPF. You might also see EIGRP or even BGP, just depending on what you're up to. These are all routing protocols, and the point of them, again, would be that you could set up a whole bunch of different networks on different routers, layer 3 switches, whatever, and then have them use that routing protocol to take the networks you've given them and share them out to others. So yeah, when multiple routers, layer 3 switches, whatever, are running the same routing protocol, they can share their routing information with each other. Okay, so I promised you to take a look at this, so let's do a show IP route. Okay, this is on an old Cisco router, but this is basically what you're still be expecting to see. And check it out, up at the top of our show IP route, we've got a key, and then below that, the actual network showing up in here. So I'm just going to grab this. I think I've made the font a lot bigger than some of the previous times, but just in case. All right, let's get a fresh one. Okay, cool. Here is our routing table on here, show IP route. Like we said, there's this key up at the top. How do we use that? Well, check it out. Next to, in this case, my first route in here, it is saying that there is the 192.168.10.0/24 network. Okay, think back. Maybe I put a link up there somewhere. /24 means the first 24 bits or 3 octets have to match up. Okay, so it knows about the 192.168.10.whatever network. And it says it's directly connected on Ethernet 2/0. And there's this C next to it, C for connected, just like we were just looking at. Now, if I come over here and do a show IP interface brief, should be able to see, there we go, 2/0, there it is. 192.168.10.55 is an IP address on that port. So 10.55 is the address on the port, but 192.168.10.0/24 is the network it has access to that's directly connected. In this case, it's not showing me the network mask over here on my show IP interface on this Cisco router, but it is a /24. All right, so that's my matching connected network. There's also all these S's listed out next to different networks here. And if we check that key up at the top, static, just like I wrote a second ago. How did those get there? I literally typed in IP space route, a network mask, and next hop. Okay, so I've got show run pipe include, in this case, 172.16.1.12. So that's saying, give me the whole running config, except, no, actually I was kidding. Pipe to include, just show me the lines with this address, 172.16.1.12. And that's this static route here. And again, how did it get there? Because I typed in IP space route and that network. And that network mask, it's for that one address, is available at that next hop. Now, a little odd here, just for funsies, it's in there twice with 2 different next hops because I typed it twice with 2 different next hops. Future video. But yes, you can have more than one next hop for the same network potentially. Okay, and so the same thing for all of these other static routes. I manually typed them in. Yay. Okay, let's go check somebody else out. This distribution OS 10-1 here, this distribution layer 3 switch. Show IP route, yes. Little bit of a different look, but same information here. We're going to see a network, the next hop that it's associated with, and some more information, maybe like the interface it's on, and maybe something about a metrics and last change, right? So like different operating systems from different vendors might show you slightly different things, but it's the same thing. It's still a routing table. And hey, look, we even have our little key up at the top. And let's see here. Our top thing on this one is an S. Do you remember? Static route. Yes. You can see it right up there. And this you'd call a default route. If you see a route that's all zeros, that is a default route. And so that's saying if nothing else matched, use this one. And in this case, it's pointing to 10.0.0.1. I'll go ahead and tell you right now, that's that core I set up. Again, a little bit odd to do the static routes to the core, but wanted to show you some static routes. Okay, and here's a connected route. The 10.0.0/30 network is available via 10.0.0.2. That's our IP address on 1/1/8 is what it thinks of its port. So I can do a show, same as before, IP interface brief, and 118, there it is, 10.0.0.2/30. Yep, it's up, it's good, right? And so the connected route that it knows about, 10.0.0.0/30, is the network address for 10.0.0.2 that's on that port. Yeah, okay. And we've also got all these O's in here like I kind of told you we would, because in this case I've set up OSPF. Open Shortest Path First is an IEEE standard routing protocol that's very common in what you might think of as campus environments where users are connected. It's been around forever, works on Cisco's, Juniper's, HP, Dell, whatever, right? Industry standard. And all of these O's here, instead of me having to type in IP route or something like that, instead I turned OSPF on this layer 3 switch, router, or whatever, and then I told it that those ports that had IPs on them, or those VLANs that had IPs on them, were OSPF networks. And that alone wouldn't have done it. But then I went to the others as well. And I told each one of them, also, let's turn on OSPF. And also on all of those ports where they're connected up, yeah, I want to run OSPF there as well, so that they're advertising themselves as OSPF routers on those networks, and they're advertising whatever networks they've got between each other. We'll go way more into depth on this in another video when we actually hit OSPF, but this either way is how it works, generally speaking, with routing protocols. Every one of them is a little bit different, and BGP is definitely its own thing. But for any of them, instead of having to do those static routes where I say, like I did up here on the core, hey, every network that I don't own is available via one of these next hops. I did a bunch of static routes. Instead, I go to this router and I say, you're a whatever router, in this case OSPF, and these are all OSPF networks. If you find any other OSPF routers, tell them about it. And I do the same thing on all of these. And in this way, I don't have to tell distribution 10-1 over here about everybody else's OSPF network. I tell it, go learn what you can from OSPF and share what you got from OSPF. And now they share with each other. And that's how I ended up with all of these OSPF networks here. Oh, and I never showed you up at the top. Hey, look, OSPF. Okay, just for kicks, I'm going to head down to another one. This is this Access OS 10-11 show IP route. Hey, look, I got some more OSPF networks here. I do have a different OSPF network in this case. This is a default route being shared through OSPF. It looks a little different. Again, we're not going to get super into detail on it, but that's why it has this OE2 OSPF, yes, but also whatever this external type 2 is. It's redistributed default route originate. Okay. But otherwise, each of these is going to have their own connected routes. And connected route, again, is because there's an IP on a port or a VLAN on here. Or static or OSPF or whatever, because that's how it learned it. Okay, and just for kicks here, just to show that this thing is working, what I'm going to do is I'm going to head down to PC1, and I am going to try and ping the loopback address. What? Yeah, loopback. That's another thing. Address of this Cisco core, which is going to be 172.16.1.0. All right, PC1. Ping 172.16.1.0. Yeah, making it. Okay, and on here, this little tiny VM, we can see that its address is 10.0.10.100 and its default gateway is 10.0.10.1. And so when I ping from here, it's going to say, look, user wants me to be able to ping 172.16.1.0. I don't know where that is. That's not on my network, so I'll send it to my default gateway. That default gateway is a VLAN, what is that, 10 up here on that access switch 10-11. All right. And then from there, it's going to use, in fact, hey, let me come over here. There we go. Already got it up. VLAN 10. There we go. The 10.0 network. 10.0.10.1. That default gateway on VLAN 10. Okay. And it's going to have that, receive that message from this, whatever, 10.0.10.100 or whatever this PC1 is, destined to 172.16.1.0, and it's going to check its routing table and see, well, how do I get there? And in this case, it's not actually listed off here. Yeah, check it out. I've got a bunch of loopbacks here, 172.16.1.1.2.11.12, and that's all of these OSPF routers, but I don't actually have an entry in here for 172.16.1.0. But if I go back over here, it worked. Somebody responded. Well, who was it? Well, that's going to match against the default route when nothing else works. That's how default routes work. It's last resort. If nothing else matches, then send it here. And in this case, the default route is either 10.0.0.9 or 10.0.0.17. Okay, so that's going to either go to this distribution switch 1 or distribution switch 2. Yeah, one of the two of them. And I couldn't tell you based on what I've done which one it sent it to. If I did a trace route, I'd see. But it's going to send it to one of the two of them. Let's go ahead and just say it went to my distribution 10.1 or 10-1. Why? Because I already got the routing table up for that. Okay, and so if it gets to here, again, over to that 172.16.1.0, that's not in the table. Yep, it's not here. Conveniently, routing tables are usually listed off, not every vendor does it, but very often listed off numerically. So, just literally counting higher as you go down. So the 172 should probably be next to each other, and they're not here. Okay, but again, check it out. A default route. And in this case, says send it to 10.0.0.1 if we've made it here. All right, let's over there. That's Cisco core. Let's head up there. And on the Cisco core, hey, look, loopback 0 is 172.16.1.0. Yep, it's up. There it is. But just a thing to keep in mind, whenever you're routing, you got to get there and back again, just like the Hobbit. And so there's the idea of return routes. Now, there's not a separate command for that or anything. It's just something to keep in mind that when you're routing, you got to get there and back again. And so, yeah, I could get to 172.16.1.0, but that router that's got that address better have a way of getting me back home again. And so when that message comes in from this 10.0.10.100, I think it was, go check. Yeah, 10.0.10.100 over to 172.16.1.0, and it lands on this Cisco. It's better be able to get back home, back to that 10.0.10.0 network. And that is why I set up a static route on here for it to return. 10.0.10.0/24 is available via 10.0.0.2 or 10.0.0.6. Can either send it back to distribution 1 or distribution 2. And whichever one of it gets them, it better have a route back to 10.0.10.0/24 as well. Yep, and they both do. Either one of them would get it back down to this access switch OS 10-11, and then from there, it knows how to get back down to its VLAN 10, of course. Ta-da! Okay, a little extra fun there. But again, I wanted to show y'all how these get in here. Did I skip anything? I didn't show you putting the IP on the port or the VLAN, just for funsies here. Let's see, 2/1. So show run interface ETH2/1. Yeah, part of the running config there. And I can see that I've got an IP address 10.0.0.1. And then on Cisco, they want you to type it out in dotted decimal for the network mask. 255.255.255.252 is this little point-to-point network, or /30 as we've seen it elsewhere. Over on these Dell OS 10s, it's going to be real similar, but over there they want you to type in the CIDR notation, the slash notation. So let's see, for instance, the other end of that cable here, yeah, 1/1/8 is the other end of that. Looks like 10.0.0.2/30. So there we go. Over here, because this is a layer 3 switch, the ports default, very generally speaking on a layer 3 switch, it'll do this. The ports default to being switch ports. And so if you want to route on them, you need to type in something like this, no switch port. You be a router. This is going to be the same on a Cisco. If you bought a layer 3 switch instead, you'd say no switch port on there. And then you can put an IP address. IP space address 10.0.0.2, in this case /30. Just this OS likes you to type the network mask this way. Okay, so that's how I put an IP on the port there. Now notice I told you I was going to set it up as OSPF and tell it, hey, there's an OSPF one. Here's the command for that in this case. IP OSPF1 area 0.0.0.0, but I just typed in area 0. We'll get into the details on that later, but that is how I can tell it it's an OSPF network. I could also show you real quick. Here's the OSPF configuration for all the ports I configured it on. And here's my real quick OSPF configuration. Router OSPF1 to turn it on. Don't worry about this. And then router ID and specify an IP address that's on here, basically. Again, this is the fast version of it. And I would have done something very much like this on all the rest of these as well. For VLAN, show you that real quick. Here we go. I'm back on this access 10-11. And there we go. For VLAN 10, I typed in IP address 10.0.10.1/24 here. And that made it a layer 3 interface, what Cisco would call an SVI, switch virtualized interface, or virtual interface, but it's the VLAN with an IP address on it. And hey, there's my OSPF config. Well, there's something else as well, but let's not worry too much about it right now. Okay. Oh man. So I wanted to walk you all through this. Again, when you're looking at your routing table, look for that letter over on the side, and that is going to tell you how it got in there with that little key up at the top. If you're taking your CCNA or CCNP or whatever, it's more likely a CCNA question, and they say, hey, how did this get here? How did they get there? They'll give you the routing table, and they'll just leave out the key at the top. You can get pretty far with like, oh, OSPF, right? is O, C is for connected, right? S is for static. When it gets into some of the fancy-ish ones, well, you just got to memorize some more, right? But that's the kind of thing to be on the lookout for. And if you've ever got an IP address that you know is on that port or that VLAN, but it's not showing up as connected in your routing table, almost certainly It's because the port or ports that it's associated with aren't working. If you got an IP on a port and the port is shut down, or not shut down, but like nothing's at the other end of the cable, or it's shut down at the other end of the cable, then if that interface is down, so is your network. If you got an IP on a VLAN and it's not associated with any working ports, also the network is going to be down. All right, y'all, this continues to be a blast. Like it if you like it. Hit that subscribe. And drop it in the comments if you've run into a problem before. Maybe on that CCNA you got mixed up on which network is which, or you run into it before where like you're sure everything was set up just right and the network wasn't showing up there, and you figured out the cable was shut down to the other end maybe. All right, y'all, have a great night. We'll see you next time. This is a test of the emergency jacket system. If this were an actual jacket, you would be so cozy. But instead I am.